So we're going to do a stoichiometry activity today. We're going to take copper sulfate, CuSO4, dissolve it in water, make a solution, react it with 6 molar sodium hydroxide, and make copper hydroxide, which you'll see is a blue precipitate. We're then going to place that on a hot plate, heat it, and decompose it to copper oxide, which will be a black powder. We'll use filtration to separate the copper oxide from the rest of the components, let it dry, and then we'll see if the mass of copper oxide we obtained agreed well with the theoretical, or what we calculated, yield based on the amount of copper sulfate. So the first thing I'm going to do is I'm going to take a beaker and weigh it. And I'll write all this down and we can look at the board later. Weighs 109.41 grams. I'm going to add my copper sulfate, and I want about 2 grams. So I don't need exactly 2 grams, but I want roughly 2 grams. And you can see the copper sulfate is a blue powder. And now it weighs 111.52 grams. So I've got a little bit more than 2 grams. I can calculate that a little bit later. I'm going to add 25 milliliters of deionized water and stir this around, and I'll get a blue solution. To that, I'm going to add 10 milliliters of sodium hydroxide solution. And when I hold this up, you'll see I've made a nice bright blue precipitate. Okay. So I'm going to take that, place this on the hot plate, see if we can zoom in a little bit. A little bit better view. And I'm going to place a watch glass on top so that if any splattering takes place, I won't have anything flying out. That'll decompose very quickly, and we'll be able to see that it's undergoing a change, because while the copper hydroxide is blue, the copper oxide is black. So when that's turned into a black precipitate, I'll know it's done. In the meantime, I'm going to set up my filtration apparatus. So my filtration apparatus, and we've done this before, consists of a ring stand, a ring, a funnel, a beaker underneath to collect the filtrate, the solution that comes through. And for my filter paper, I'm going to weigh the filter paper, and it weighs 0.68 grams. And I'm going to write on it the mass, just in case I forget. And I'll write it on both sides, so no matter which way I fold it, I'm good. I'm going to fold it in half, increase it. Fold it in half again, increase it. Open it up so I kind of have a cone. 3 flaps on one side, 1 on the other. Put it in. If it doesn't seem to stick, I can take my wash bottle and just add a little bit of water. Any water we have is going to be dried overnight, so we won't have to worry about that. And then we're going to let this heat up. It won't take very long, and we'll see the black precipitate forming. And then we'll go ahead and do the rest of our lab and our calculations. So let's calculate the moles of copper sulfate and then go back and look at our product. So our empty beaker was 109.41 grams. Our beaker with the copper sulfate was 111.52. And that means we have 2.11 grams of copper sulfate. we can get the molar mass of copper sulfate by saying there's 1 copper, 1 sulfur, and 4 oxygen, and that all adds up to 159.6. So I'm going to say 2.11 grams copper sulfate, and depending on how you're doing this for your teacher, you could do it one of 2 ways. I'm going to just show you the mole diagram way, which is you divide it by the molar mass, and you'll get the number of grams of copper sulfate, which is 0.01, number of moles rather, 32 moles. I could also use my dimensional analysis or factor label method and go 1 mole of copper sulfate, 159.6 grams of copper sulfate. And I'll get the same answer. So now I know the moles of copper sulfate, my starting material. Let's go back and look at our product. So now my copper hydroxide has had a chance to decompose by heating to copper oxide, and you can see it's a completely different looking substance. Now we have a black powder, whereas before we had a bright blue solid. This has had time to cool, so now I'm going to get set up. I'm going to weigh my piece of filter paper, putting it on the scale, and it weighs 0.68 grams. Then I'm going to take my filter paper, fold it in half, fold it in half again, and here's my filtration apparatus. I have a ring stand, a ring, a funnel, and a beaker to collect the filtrate. I'm going to open up my filter paper, so there are 3 flaps on one side and 1 on the other. Put it in the funnel. If it doesn't stick, I can add a little deionized water to help it stick to the side. The water will all be evaporated overnight. Now this has had a chance to cool, so I can pick it up. I'm going to pour my mixture through the filter paper. The filtrate will consist of all the water, any ions that are dissolved, but the copper oxide solid particles won't go through the filter paper. So I'm going to pour that through, and we can see the filtrate coming through. Now, I still have a great deal of product in here, so I'm going to use my wash bottle and rinse this a couple times, pour it through, and I'm going to do that 4 or 5 times. Okay, because my goal is to get every bit of the product out. Now, obviously, you don't need to watch me use a squirt bottle. So now it's filtering, and after it's all done filtering, I'm going to add some more water, because what happens in here is there are lots of unreacted ions. There are sodium ions, there are sulfate ions, there are hydroxide ions, and because they all have charges, they can stick to anything else with the charge, like the ions in copper oxide. So I'm going to pour a fair amount of water through this several times. And again, I'm not going to show you this the whole time, but I'm going to end up with a whole lot of water in my beaker, which I don't need to worry about. And no matter how much water is on here, it's all going to evaporate overnight in an oven. So I'm going to do that again. And again, I'm doing that so that any unreacted ions will be washed away. Because if they were still there, they would stick, and you never know if somebody will ask you how that might affect your final answer. So now my copper oxide is dried. It's been in the oven overnight. All the water that was in there is now evaporated. I can weigh this, and the copper oxide and the filter paper weigh 1.79 grams. So now we can go calculate the mass and the number of moles of our copper oxide. So now let's calculate our theoretical yield. which is what we're supposed to get if the chemicals all read the chem book. So here's our balanced equation. Copper sulfate reacts with sodium hydroxide, makes copper oxide, and the sodium sulfate, which we washed away. So there's a couple ways you could do this. One is to simply recognize they're in a 1-to-1 ratio. The other is to use a little proportion. You could also use dimensional analysis. But when you solve this, you'll get 0.0132 moles of CuO that you're expecting to get. Multiply that by the molar mass of 79.5 grams per mole, and we're getting a theoretical yield of 1.05 grams. The next thing we'll do is we'll calculate our percent yield. So to calculate the percent yield, we need two pieces of information. We need the amount of copper oxide we actually obtained, which is sometimes called the experimental yield, and that was 1.11 grams. When we did our calculation based on our starting material, we got that we expected 1.05 grams. That's called theoretical. That ratio, 1.06, gives us a percent yield of 106%. So now what we're going to have to do is try and explain how did we get a little bit more than we were expecting. In your lab, you'll be given a data set, just like the ones we've worked through. You might be a little bit more than 100%, you might be a little bit less, and either way, your job will be to come up with a logical, sensible reason where you could have not gotten 100%.